Welcome to this explainer. Every time you log into an app, buy something online, or just mindlessly scroll your feed, there is a highly complex architecture working tirelessly behind the scenes. Today, we're exploring the foundation of that digital world, the different types of databases within a database management system, and how they uniquely handle our data.
Here's our roadmap for today. We'll start with a quick intro to database management, look at early models like hierarchical and network, dive into the relational standard, check out object-oriented storage, talk about the massive rise of NoSQL, and then wrap it all up with a quick review.
All right, let's jump right into Section 1, Intro to Database Management. So at its absolute core, a database is really just a system used to store and manage data efficiently. But here is the critical part. Your choice of database completely depends on the application you're building. Think of it kind of like vehicles: a sports car, a heavy-duty pickup truck, and a massive cargo plane. They all require highly specific engines to run right. Software applications are the exact same way. They demand specialized databases to manage their distinct data needs. Because of this, databases are categorized based entirely on how they organize and retrieve that information.
Which brings us to Section 2, Early Models, specifically hierarchical and network.
Let's kick things off with the hierarchical database. In this early model, data is organized in a super strict tree-like structure. It operates entirely on a parent-child relationship. Honestly, the best way to visualize this is to picture a traditional family tree, or a standard corporate org chart. In this system, one parent node can have a whole bunch of children, but one child, it can only ever have one parent. It's incredibly straightforward.
But moving from the hierarchical to the network model brings a pretty crucial shift. While the hierarchical model forces that strict one-parent rule, which, by the way, is actually perfect for things like a company management system or your computer's own file system, the network database totally breaks that open. Now, a child can have multiple parents, creating what we call a many-to-many relationship. A classic example of this is a student and course management system. One student is connected to many courses, and one course is connected to many students. So it becomes this highly complex web of data.
Now, both of these early models share a similar set of pros and cons. On the plus side, speed. Because the structures are so clearly defined, they offer incredibly fast and efficient data access. The hierarchical model especially has this beautifully simple structure. But the downside is massive. As your data grows, these complex relationships, especially those messy many-to-many webs in the network model, just become incredibly difficult to manage and maintain. The rigid structure literally becomes a maintenance nightmare when things get too complex.
So, we evolve. Let's head into Section 3, the Relational Database Standard.
Relational databases completely ditch those old tree and web structures for a highly organized filing cabinet, or basically a spreadsheet model. Fittingly, we're essentially using a table right now to explain how tables work. In this model, data is stored strictly in the form of tables. The rows are called records, and the columns are your attributes. The real magic, though, happens when you need to connect different tables together. You do that using specific identifiers known as primary keys and foreign keys. It just keeps everything so beautifully organized.
And I can almost guarantee you've interacted with applications powered by these systems. We're talking absolute heavyweights like MySQL, Oracle, PostgreSQL, and SQL Server. This is hands down the most widely used database type in modern applications today. And for good reason. They're generally very easy to use, they offer incredibly high security, and above all, they guarantee vital data consistency. I mean, when you're dealing with financial transactions or secure user accounts, that level of strict consistency is absolutely non-negotiable.
Moving right along to Section 4, Object-Oriented Data Storage.
Our fourth category is the Object-Oriented Database. Now, this is a system built specifically to align with programming code. Instead of forcing data into flat tables, data here is stored as objects, exactly like it is in object-oriented programming. It natively supports programming concepts like classes, inheritance, and methods. This makes it an absolute powerhouse for handling highly complex data in advanced applications. Think heavy multimedia apps or complex AI systems. But when developers are comparing the two, they face a pretty distinct trade-off. The relational database is your highly secure, relatively easy-to-use standard that is just perfect for standard data. The object-oriented database, on the other hand, works phenomenally well with programming languages and handles exceptionally complex data without breaking a sweat. The catch? It is significantly more complex to build and maintain compared to straightforward relational tables. You're basically trading standard simplicity for complex capability.
All right, Section 5, the rise of NoSQL.
Our fifth and final major category is the NoSQL Database. Fun fact, NoSQL actually stands for Not Only SQL. These databases were built as a direct response to the limitations of that rigid relational model we talked about. They are massive, highly flexible warehouses designed specifically for handling exceptionally large-scale and unstructured data. Basically, when the data gets huge, varied, and just plain messy, NoSQL is the tool you want for the job.
Because of this design, NoSQL is the engine behind some of the fastest and largest apps on the planet. It's widely used for social media platforms, massive big data applications, and real-time web apps. Look, if you're scrolling through a personalized, endlessly updating feed right now, there's a very good chance a NoSQL database is working furiously behind the scenes. Some of the big names you'll hear in this space are MongoDB, Cassandra, and Redis.
The advantages here are really all about scale. We're talking incredibly high speed, massive scalability, and completely flexible data storage. You don't even have to define a perfect table before you start saving data. But as always in tech, there's a trade-off. The primary disadvantage is that NoSQL is far less structured compared to relational databases. By abandoning that rigid, tabular structure to gain all that speed and flexibility, you're giving up some of the strict organizational guarantees that relational models just give you natively.
Let's bring it all together in Section 6, Reviewing the Database Types. To quickly summarize our evolutionary journey today, we started with the hierarchical database and its strict single-parent tree structure. That evolved into the network database, which opened up multiple relationships. Then came the undisputed industry giant, the relational database, organizing everything cleanly into a table format. For advanced programming needs, we looked at the object-oriented database, leveraging object-based storage. And finally, for massive unstructured scale, the NoSQL database brought us totally flexible and modern storage.
Understanding these types is really just the beginning of mastering data architecture. The next step in our learning journey will be zooming out to explore the overall pros and cons of using a database management system as a whole. You definitely won't want to miss that. But for now,